IB Environmental students, we're going to start talking about our last subtopic, 3.8, ecological footprint, on our way to finishing all of topic 3. If you need extra space, write on a separate piece of paper. Make sure to make the connection to what objective you're writing about. All right, let's begin. So, when we're going to be talking about ecological footprint, we should probably first define it. And it is defined as the area of land that would be required to provide the resources and assimilate waste for a particular population. We're going to use the units usually of global hectares, GHA, as the abbreviation for that unit. This can be usually referred to as a whole population's ecological footprint. For instance, I could say the footprint for the U.S., or I could say a footprint for the average person in the U.S., and that would be per capita or per person. I could refer to either, right? So let's keep going. And last but not least, let's relate this to a really important idea of how much the land can provide, because an ecological footprint depends on that land space and how healthy that land space is. So biocapacity is the ability of an area to generate ongoing supply of said resources and said waste, being able to absorb it and deal with it. So if I have a lower biocapacity, my land is not healthy. So I'm going to need even more land for my ecological footprint. So if I destroy the land because my ecological footprint's growing, my biocapacity for that land's probably going to go down, which is going to in turn impact my ecological footprint, relating to a positive feedback loop. So let's talk about what goes into calculating semi-simple footprint. And I have an asterisk here because simple footprint, all things considered. This is very overwhelming. We're going to talk about this guy in class. It is in your objectives. I'm going to talk about some of the key factors that go into your calculation. For instance, you guys, when you did it in class, you had to survey what the types of food you ate, which is related to how much cropland fisheries are needed for the things you eat, whether it's vegetables, meat, or fish. Or those things are also going to include any imports that your population required. That food land is really a big deal, and more meat is going to increase that food land a lot. It's also about consumed land. In an urbanized area, there's going to be more homes, more roads, and that's going to increase this number as well. In a more rural area, this number goes down, right? The next one is the energy land, also known as sometimes the carbon footprint. As we're kind of combusting our fossil fuels, whether that's oil or natural gas or coal, those things are going to release carbon dioxide during that combustion. Well, this is going to account for the amount of land that is needed to absorb that carbon dioxide. And that's a big deal because right now we're using a lot of non-renewables that are fossil fuels that produce this CO2. Last but not least, what forest land is used to produce different products such as wood, paper, and probably even other non-renewables that are not on this list because these are replenishables, such as minerals, right, that go into maybe making your phone, for instance. So all of these things are going to be related to our footprint calculations, and you're not going to have to calculate it by hand, but you're going to need to analyze data, and we'll practice that in class when I see you. So next we're going to talk about comparing these eco-footprints for MEDCs and LEDCs. And we're going to use these terms debtor and creditor, right? When you're in debt, is that good? No, it's bad. You don't want to be in debt. And we don't want to be in debt for eco-footprints either. Now, if I'm looking at this map, it says the ones in debt are red, and the ones that are in credit are in green. Green for good, red for bad in this case, right? And I'm going to notice, U.S. is red. We're in debt with regards to our eco-footprint, meaning, and we're dark red, our footprint is more than 50% of our biocapacity. We're using over half of the capacity that we're supposed to be using. We're taking up way more land than we should be. Versus maybe this green area here, they have more biocapacity than they're even using within their eco-footprint. So, in essence, we are using more than half of what we're supposed to be using. We're kind of taking it from these guys, right? And what you'll see is a trend. More of the MEDCs are red than the green ones, right? And the green ones tend to be some of our more LEDCs. So there's this pattern that we can see unwinding here. Furthermore, we could also look at this through the number of planet Earths that would be needed for different places. Notice that the U.S. is got 5 planet Earths that we need. We are 4 over. There's only 1 planet Earth. Versus the LEDC India that we've had case studies about, where they're only using 0.4. So we are essentially taking from some of the more LEDCs as an MEDC. But on average, because not all the world is MEDC, thank goodness for now, we are on average using the amount for 1.4 Earths. But there's only 1 Earth. And I'm going to tell you right now, people don't like being an LEDC. They want to have the same living standards as you, as an MEDC. So everybody wants to live like this, but there's not enough Earth for this. And that's what we're going to talk about next. So some countries have made some national policies to try to deal with the fact that they were resource using so much and their footprints were growing. Those are going to be China and France that we're going to talk about through case studies really quick. So China came up with a policy, and both of these actually deal with the fact that their populations were struggling. So China, as we know, had the one-child policy. We're going to refer to this as anti-natalist, or being lowering our birth rates, pretty much. That's their policy. So they were originally kind of in this demographic stage as an LEDC, and because of their legal one-child policy, right, that we've talked about before, they had a drastic shift to move closer to an MEDC, but not all the way quite. We're kind of in the developing area because they've lowered their birth rates. Comparatively, France, they wanted more babies, and we call that pronatalist. They are in stage 3 or 4, and they were worried that they were going to have a declining population like Japan, which is not really great either. So they had all these financial incentives and even banned some contraceptives so that the women would really have more babies, and that really helped them because they ended up increasing their fertility rates, which was really positive for their population, unlike Japan, who's struggling with a declining population. So these things are supposed to help those populations deal with their carrying capacity issues, ecological footprint. So I encourage you to kind of dig deeper into this idea of those connections. There also are international policies. The one we're going to focus on is the UN's Millennium Development Goals. So pause right now and do note these were made in 2000. The UN hoped that we'd meet these goals by 2015. We've talked about them before, so I'm not going to go over all them all now, but I want you to connect how these could potentially help ecological footprints be lower. Lastly, we're going to look at the fact that technocentrics believe that new discoveries will provide solutions to old problems. But not everybody's technocentric. Some people are anthropocentric and some people are ecocentric. And yes, we're going to have to make those connections to old ideas from earlier in the year right now. And even earlier in this topic where we talked about that resources are valued in many different ways, such as the economic value might be more important to someone, the ecological value might be more important to somebody else. The scientific value is going to definitely be really important to technocentrics. This guy, ecological, more important to someone who's ecocentric. And lastly, intrinsic value, that maybe the land might just be meaningful to someone. Well, guess what? Since not everybody agrees with this, we are having some problems. We are focusing more right now on the planet for some of the ones that are more along the lines of the economics, right? And because of that, there is some problems with the environmental sustainability of some of our choices. And we might need to really look at the fact that we're going to need to be careful because our extinction could become a major concern. Why? Well, our resources aren't being used sustainably, and we are starting to deplete our natural capital. Summarizing things from all of this topic, we are deciding more often than not to use non-renewables rather than renewables. We need to focus more on sustainable agriculture and soil conservation and really decrease our soil degradation. We need to figure out ways on conserving our water use and lowering our pollution in the water. We need to figure out ways of trying to lower the population growth because it's really large right now, and we are potentially going to overshoot carrying capacity wherever that is, because we decided in class it's hard to know, and figure out ways to lower our footprints. We're consuming resources too fast, and even some technological advances, like a technocentric might think, might not always be the final solution. Maybe they will be, though. And even with those technological advances, we might increase carrying capacity for a short bit of time, and we might meet current demands, but I'll tell you right now, we have to be very careful because we might not always know what's going to happen in the future. And on that note, I do encourage you to think about sustainability as the solution. I know these notes were longer than you were hoping, but I think they're covering a lot of stuff which will allow us to review almost all next class for your big topic 3 exam. All right, thanks guys, bye.